Welcome back to Aurora Tech Channel. Today, I will review the Thinker X400 from Eryone. Eryone has been supplying filament to our channel for a couple of years, and as you've seen, I use a lot of their TPU and ABS filaments in my videos. They are preparing to launch a Kickstarter campaign featuring the new Thinker X400 3D printer, a large-scale CoreXY machine with a 400x400x400mm print volume. It is fully enclosed, with a sturdy frame supported by 840x40 aluminum extrusions. The sides and top are covered with clear acrylic, while the front door is made of tempered glass. The entire machine is quite heavy, weighing 130 pounds. The motion system features linear rails on the X and Y axes, which are driven by high-torque 60mm NEMA 17-stepper motors rather than the 34mm motors found in regular-size machines. The Z-axis uses a quad gantry design controlled by 4 independent stepper drivers and powered by 448mm NEMA 17-stepper motors. This setup allows the gantry to level itself automatically. During printing, the platform remains stationary, while the gantry moves up as the print gets taller. The print bed is a 10mm thick solid aluminum AC-powered heated bed, capable of reaching a maximum temperature of 120 degrees Celsius. For the print surface, my test unit came with 2 spring steel print sheets. One is a double-sided textured PEI sheet, while the other has a PEO and textured PEI surface. The direct drive extruder features hardened steel gears with a 4.3 to 1 gear ratio. The high-flow hardened has a claimed maximum flow rate of 35 millimeters cubed per second. The 70-watt heater can bring the nozzle up to its maximum 300 degrees Celsius in about 2 minutes. By default, the printer comes with a hardened steel nozzle, allowing users to print abrasive carbon fiber blended filaments right out of the box. For part cooling, there is no auxiliary fan, but the print head is equipped with 3 4010 turbo blowers. Additionally, there is an exhaust fan with an air filter located at the top of the machine. For bed leveling, it uses strain gauge and the nozzle to probe the bed, and the Z offset is automatically set. The machine runs Clipper firmware on an MK S-Pine motherboard, making it an open system where users can log into the Linux OS to install plugins, scripts, or any additional software. The web interface is using Mainsail, and the 4.3-inch touchscreen runs standard Clipper screen UI. The processor is an ARM Cortex A53 quad-core with 1 GB of RAM and 32 GB SD card as storage. My test unit came with an Ethernet connector and a USB Wi-Fi adapter, but Eryone has confirmed that the final version will include a built-in Wi-Fi module. Other features include a side-mounted spool holder, an electronic enclosure for easy access, and a filament sensor integrated inside the print head, which supports automatic filament loading. The Kickstarter Super Early Bird price is set at $1,299, and the campaign is expected to launch in about 10 days. Please keep in mind that everything on Kickstarter is still in development. Unlike an in-stock ready-to-ship machine, backing a Kickstarter project comes with additional risks and uncertainties. Please do your own research to determine whether Kickstarter is something you're comfortable with and whether you're willing to take on those risks in exchange for a better deal. I'd like to thank Eryone for sending us this machine to review and for sponsoring today's video. Even though this is a sponsored review, we won't hesitate to point out any cons with the machine. With that said, let's get started. The machine came in a large box. When I first opened the cover, it seemed upside down, but it actually made sense since you just need to turn it 90 degrees and the box can be removed. The whole machine is pre-assembled. You only need to attach the filament guide and spool holder. My test unit came with an external USB Wi-Fi adapter instead of the built-in module that will be included in the final version. I will just use Ethernet to test the machine. The screen is a standard Clipper screen interface. I navigated to the calibration menu, selected Calibrate All, and let it run. It started with PID tuning for the nozzle and bed, during which nothing appeared on the screen, just a few minutes of waiting before it restarted, and moved on to input shaper calibration. In the Mainsail web interface, I could see it testing different frequencies. After another restart to save the values, it proceeded with quad gantry leveling, probing all 4 corners, and adjusting the gantry until everything was level. With calibration complete, I loaded some filament and started the first print. By default, the machine performs gantry leveling and mini bed leveling over the printing area before starting. The Benchy printed at a fast pace, but not extremely fast. It didn't seem like a fine-tuned benchy optimized for a speedboat test, but rather a regular benchy using the default slicer profile. For a sound test, I placed a meter 1 foot away from the table. With the doors open, the noise level was around 60 decibels. Once the doors were closed, it dropped to the low to mid-50s. The print finished in 41 minutes, including prep time, so the actual printing time was about 35 minutes. Aside from a bit of stringing, the print quality was excellent. The bottom adhered well, cooling performance was solid, and there was no under-extrusion. Unlike other fast benchy test prints that increase line width for speed, this one appeared to use a standard line width for a 0.4mm nozzle. Then, I will start the clearance test and print the number slider. It seems the Auto Z offset is working fine, and the first layer has proper clearance. The print finishes in 2 hours 49 minutes. Due to the slicer settings on this large machine, it's slightly slower than the average 2.5-hour print time for a standard size CoreXY machine. The top surface looks excellent with almost no stringing, and the bottom adheres perfectly to the textured PEI sheet. All tiles move freely. Next, I will test retraction by printing the honeycomb box. The extruder needs to extrude a tiny bit of filament, retract immediately, and then move to the next spot. The print finishes in 2 hours and 45 minutes, including prep time, and is in line with the speed of a standard-sized machine. The bottom is just all right, some patterns didn't print well, and there is some stringing. The sides look better, with all patterns printed without breaks, but also with a little bit of stringing. Overall, the extruder is working pretty well, and the results are comparable to those of top machines that have printed the same model. Next, I will test tolerance to see if parts fit together by printing a simple geometric model. On my first attempt, the result was not good. On the square side, it can barely clear 0.1mm, while the cylinder side performs better, but can still only clear up to 0.75mm. Since this machine doesn't have a LiDAR sensor like the Bambu Lab X1 or a secondary camera like the Creality K2 Plus for calibrating flow and pressure advance, I had to calibrate it manually. I used Orca Slicer to print test patterns and adjusted the parameters to match the filament I used before restarting the print. After calibration, both the square and cylindrical sections achieved a perfect score, clearing up to 0.05mm and stopping at 0 clearance. Then, I will print the Robo Alpaca to test surface quality. This time, surprisingly, the print finished in 4 hours and 18 minutes, which is faster than the average 4.5 to 5 hour printing time. It's even faster than some smaller CoreXY machines. So let's take a look from all 4 angles and compare it with other printers. Compared to large clipper bed slingers, the Comgro T500, which has a 500mm cube print volume, is slower, and its surface quality is not as good as the X400. The Neptune 4 Max, with a 420 by 420 by 480mm volume, and the X400 still delivers slightly better quality. When comparing it to other CoreXY machines, the Creality K1C, which is a standard size CoreXY, print faster and has marginally better surface quality. Against the Mingda 400D, which has the same print volume but is a fully enclosed IDEX rather than a CoreXY, the X400 is much faster and has better surface quality. However, when placed side by side with the Creality K2+, the K2+ is significantly faster and has much better surface quality. In terms of surface quality, I would say that the X400 performs better than large bed slingers, but among standard-size CoreXY machines, it's about average. Next, I will attempt a large print, starting with this unicorn model. I set the height to 300mm, as a 1 kilogram spool should be enough to complete the print, assuming the slicer's estimate is accurate. I will use the 0.24mm layer height profile to speed up this large print a bit. I switched to the PEO print surface. Normally, PLA printing on a PEO surface shouldn't require glue, but since this is a 20+ hours print, I'll apply some glue for extra adhesion. After about 20 hours, the filament ran out. While I was right next to the machine at the time, so I tried to pause the print, change the filament, and resume. However, once the pause print button was pressed, neither the load-unload macro nor the resume button responded. In a later firmware update, this issue was fixed, but for now, I have no choice but to stop the print. That said, I'd like to share a way to recover a print like this. By comparing the actual print with the slicer preview, I estimated that about 330 layers were still unprinted. To salvage the print, I moved the model below the build plate and printed just the final 330 layers. Instead of printing the full file, I first let it print a few layers and then stopped the print to align it with the existing model. It turned out that 330 layers were slightly too many, so I adjusted and printed 327 layers instead. This time the alignment was pretty close. I guess printing 326 layers would be perfect. Once glued together, the model still looked great. The rainbow PLA transition turned out beautifully, and the second part actually aligned quite well with the filament's color gradient. Of course, the model still shows some imperfections when zoomed in really close, but at least I don't have to waste a whole spool to reprint it. Now, I will test a large bed-size print by making a wall-mounted filament rack for the Prusa MMU3. It seems that the Auto-Z offset for higher temperature filaments, like PETG, is not as precise as it is for PLA due to heat expansion. The first layer was squeezed too low. In a later firmware update, this issue was also fixed, but for now, it is what it is. After a few layers, the overly squeezed first layer is completely covered, so I'll just let it print. The print finished in 11 hours and 19 minutes. However, despite using a brim, there was still warping at all corners. Besides that, the corner of the PEI sheet lifted. This indicates that the warping force is too strong, to the point that the magnetic sheet isn't holding the PEI sheet well enough to resist it. In a later test, I found that the bed temperature not being as high as I had set. The issue was fixed in a later firmware update, but we will discuss it in more detail later. Since this printer is fully enclosed, but the enclosure is quite large and lacks a heated chamber, I want to see if it can handle a large ABS print. As the last large PETG print had some warping issues due to the bed temperature, I tried setting it 15 degrees higher than the usual 100 degrees Celsius for ABS to compensate for that. Just like with PETG, the AutoZ offset squeezed the first layer too much, but for ABS, I would rather it be slightly over-squeezed to improve bed adhesion. After the second layer, the print looked fine, and I couldn't see any signs of an overly compressed first layer. After enclosing the printer and letting the print run for an hour, the internal temperature reached about 33 degrees Celsius, which is almost 20 degrees Celsius higher than my 14 degrees Celsius room temperature, which is pretty good. However, since I placed the thermometer on the gantry, I expected the temperature to drop as the print got taller and moved away from the heated bed. By the time the print was nearly finished, the temperature had dropped to 26 degrees Celsius. The print completed in 10 hours, which was longer than the expected 9 hours and 19 minutes, but surprisingly the ABS adhered perfectly with zero warping. The surface looks clean with no layer cracking, and the bottom layer is smooth. Even though the first layer was over-squeezed, it didn't negatively impact the print. The result turned out almost perfect. Then, I will try some TPU. If you've watched my videos, you may have seen that I use a lot of Eryone TPU filament, so I'll test a TPU tire with this machine as well. This TPU is super easy to print. I simply store it in a camera cabinet that maintains 30 to 40% humidity, and it usually prints fine. This print took about 38 minutes. The surface is clean, though there is some stringing on the inside, but overall the print is decent. Since this machine comes with a nozzle featuring a hardened steel tip, I will also print some polycarbonate carbon fiber PCCF. This is a camera grip for my Leica M3, which I recently won in a bid on eBay at an unbelievably low price. When the extruder travels across distances to print these two parts, it strings a little. The print took 1 hour and 26 minutes to finish. The strings can be easily cleaned up with a flush cutter. Like previous high-temperature prints, the bottom layer is over-squished, which is more noticeable when using dark filament. However, this PCCF grip still looks awesome on my 70-year-old camera. Finally, I will print a large PLA sheet to test the first layer. The PLA sheet was printed all right. Most parts look good, but the left side of the sheet is a bit too low. The sheet can be peeled off without line separation, so while it's not a perfectly even first layer, it should still be good enough for most prints. Okay, let's talk about the pros and cons of this machine, starting with the pros. 1. The machine uses a quad gantry that automatically levels itself. This design is well suited for large and heavy prints as the platform remains stationary, while the gantry, driven by 4 independent 48mm NEMA 17-stepper motors, moves up as the print gets taller. 2. It uses 8 large 40x40 aluminum extrusions as the main structure of the frame, with other metal parts like the metal base plate, thick aluminum bed, and linear rails, making the entire machine over 130 pounds, so it's super sturdy when printing at high speed. 3. It uses a 10mm aluminum heated bed. The increased thickness improves heat distribution across the surface. The added rigidity also makes the bed more resistant to bending or warping over time. 4. The X and Y axes use linear rails, and the motion system is driven by 2 high-torque 60mm NEMA 17-stepper motors compared to the more common 34mm motors on regular machines and 40mm motors on larger machines. 5. The extruder pushing force is strong, and it also features a door for easy access. I didn't experience any filament jams throughout the entire test, but in case maintenance is needed, the accessible design makes it easy to open up and service. 6. It uses 3-part cooling fans on the print head. Even though it doesn't come with an auxiliary fan, it still provides sufficient cooling while keeping the printer quieter. It checks all the boxes for fast printing, striking a good balance between print speed and quality, and outperforming other large-scale bed slingers so far. 7. It uses native Klipper firmware, the Klipper Screen UI, and Orca Slicer. You can print within your local network or completely offline, unlike some brands that require you to use their cloud servers. Since it runs Armbian Linux, the printer functions like a standalone computer, allowing you to run your own plugins, scripts, and install software as needed. They also offer a cloud service for managing multiple machines, which I will discuss in more detail later. 8. For other small improvements, the electronics are housed in a separate metal enclosure on the side, making access easy. It has a 32GB micro SD card that provides over 23 GB of free space for your G-code files. The filament sensor is integrated inside the print head, so you don't have to feed the filament through a separate sensor on the side or back like other machines, and it also loads filament automatically. The 70-watt heater on the Howden heats up rapidly, bringing the nozzle from room temperature to 300 degrees Celsius in less than 2 minutes. Now for the cons. 1. The Z offset is set too low for higher temperature filaments like PETG and ABS due to heat expansion. The Z offset algorithm should compensate for this. When using the early firmware, I had to manually raise the nozzle by 0.05 to 0.1 millimeters for high temperature prints to achieve good results. However, the latest firmware update on February 17th has brought improvements, and so far, it is looking much better to those I printed a few weeks ago. 2. In my early tests, I found that the bed temperature was consistently 10 to 20 degrees Celsius lower than the set temperature. As a result, I experienced warped prints, and I had to set the bed temperature 5 to 10 degrees Celsius higher for PLA and 15 degrees Celsius higher for ABS to achieve good results. The latest firmware seems to fix this issue as well. I retested it, and the temperature is now accurate. When heating the bed to the maximum 120 degrees Celsius, the center of the magnetic bed reached 113.6 degrees Celsius, while the edges and corners were close to 110 degrees Celsius, which falls within an acceptable range. However, when printing a 405mm long large model, the magnetic sheet fails to hold the corners of the PEI sheet, causing it to lift. Generally, this magnetic sheet and PEI spring steel sheet setup works well on standard size machines, but on a larger 400x400mm bed, strong magnets instead of a magnetic sheet should provide a stronger holding force. Using a thicker single-sided steel sheet as the print surface could also help. 3. Another issue I experienced in my early tests was that the unload button on the screen didn't work during a mid-print filament change after pausing the print. This issue has also been resolved in the recent firmware updates. However, the printer still lacks power loss recovery. There are various solutions available for Klipper to address this. Given the size of this printer and the potential for multi-day large prints, the need for this feature increases significantly. 4. It has no heated chamber. While I was able to successfully print some mid-sized ABS parts in my cold garage, and the fully enclosed temperature can rise by about 15 degrees Celsius, a heated chamber would be preferable for larger prints. But, as not everyone needs a heated chamber and willing to pay for it, maybe they can consider offering this as an optional upgrade module. 5. Eryone has also developed an optional cloud-based multiple printer management interface. It seems they aim to create something similar to Prusa Connect, allowing users to upload G-code files, categorize them for easy file management, and assign jobs to specific printers. However, at this stage, the platform appears to be an early-stage prototype. The current UI and overall design are not very intuitive. Let's see what improvements they make in the future. In conclusion, the overall design of the Thinker X400 as a larger CoreXY printer is good, and the hardware such as the quad self-leveling gantry, thick aluminum bed, and linear rails is solid. In my early tests, some prints were affected by firmware issues such as auto Z offset, bed temperature, and certain macros not functioning properly. However, as of today, those issues have been largely resolved, and the printer is now working quite well after the latest firmware update. Since this machine is still in the pre-production stage, if Eryone can fine-tune the firmware and hardware to address minor issues, it would have great value as a DIY-style large-format machine. Additionally, if they can further refine the cloud-based multi-printer management web interface and function more like Prusa Connect, it would add a lot of value. If you were to source all the parts, have them shipped from different vendors, and assemble a printer of this size yourself, the total cost would likely exceed their Kickstarter price. If you're interested in learning more about the Thinker X400 and want to get their super early bird price, I included their Kickstarter link in the video description. Once again, I want to remind you that everything on Kickstarter is still in development. Unlike an in-stock ready-to-ship machine, backing a Kickstarter project comes with additional risks and uncertainties. Please do your own research to determine whether Kickstarter is something you're comfortable with and whether you're willing to take on those risks in exchange for a better deal. Eryone also sent me a list of planned changes, which mainly includes some minor improvements and cosmetic adjustments. I've included that list in the video description as well. Don't forget to also check out my website auroratechchannel.com for the latest recommendations for 3D printers, laser engravers, and CNC machines. My price tracker scans popular brand websites and updates prices hourly to help you find great deals. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.